For many years, our automotive customers have used the VBOX, which is a GPS-based logging device that allows them to take measurements from the car for acceleration, braking, coast down, durability, and also for verification of ADAS sensors, such as cameras, LiDAR sensors, and radar sensors. Quite recently, they've wanted to do some more repeatable testing indoors, and this is so they can control the conditions much more accurately. So they want to fill the room full of mist, fog, they want to have bright sunlight, darkness. So what they need to do is they need to measure exactly the same parameters, but indoors. So they've asked us to develop a VBOX that can be used in exactly the same way, but indoors. So for the last 4 years, we've been working on this system. And it's based on UWB, which is ultra-wideband radio. And the benefits of ultra-wideband radio are that it is a very short radio pulse and very, very low power. So inside a building, you don't get as many reflections from the metal parts and the walls of the building, so you can get a lot more accuracy than you would if you used a traditional radio or radar system indoors. We also use an inertial measurement unit in conjunction with the ultra-wideband radio, and this fills in the gaps and smooths all of the measurements and makes the velocity extremely accurate. So the idea is a customer can go testing on his normal test track with a VBOX, and he can be running RTK 2 centimetre GPS outside, measuring the distance between two cars or the time to collision with an AEB test. But they can also then drive indoors and carry on doing exactly the kind of tests that they did outside, but with exactly the same accuracy of 2 centimetres. In fact, the more we've used our system, the more we realise that it is actually slightly better than GPS, because the acquisition time is only 0.2 of a second. So if you drive from outside to inside, you get a lovely seamless transition of the velocity and the position as the vehicle enters the building that has the VIPS system fitted. When you drive outside, it takes 2 or 3 seconds for the GPS to come in. So the VIPS system is actually running a lot quicker and a lot more accurately under those kind of conditions than GPS does. So how do we set the system up? Well, in the room here today, we have 10 beacons, and they are on tripods. They're battery powered. They only use about 1 watt each. They're not connected together. We just put them in fairly random places throughout the room at different heights. Then we survey them in, and we survey them in using a total station, which is a surveyor's tool to accurately position something to a reference point. So once we've done that, we enter these positions into the VIPS system on the car, and when the car's driving around, it can measure the exact distance to each beacon in turn, and from that, it can triangulate its position and also work out its speed. The other scenario is you might have a tunnel on your test track, in which case we can put a number of beacons in the tunnel. The maximum number of beacons is 250, so we can cover quite a large distance with that. But you can have a set of, say, 10, 15 beacons in a tunnel on your test track. So as you're driving around using high-precision GPS, you won't lose that precision or accuracy when you're driving through the tunnel. So you can carry out all of your normal tests using the same standard equipment and software as you would do if you're using VBOX with GPS outside. A very useful application for the VIP system is in a multi-storey car park. If you're testing auto parking, for example, you want to validate exactly what the car's doing, the angle of the car, how close it is to the car parking bays, and what it's doing as it's going from floor to floor. With the VIP system, you can have a temporary setup, so we'll provide some tripods and battery packs for the beacons, and you can set this up, and you can either survey them in very accurately using a total station, or you can use our self-survey, automatic self-survey. Now, the self-survey just requires you to roughly enter to within about 5 meters the position of each beacon, so you can just measure it out using your own feet. Then the system will spend about 5 minutes interrogating all of the beacons, working out all the angles, and then it will be accurate to about 5 to 8 centimetres. And that whole setup, you can set up one floor of a car park, that might take 20 minutes. But if you're using a total station, that might take about an hour. So it does depend on what level of accuracy that you require. One interesting application that we've been asked a number of times now is, can it work in an ice rink? Because many tyre companies are using ice rinks nowadays to do brake testing on their winter tyres. And yes, you can set it up very quickly. In less than an hour, you can have a full speed and position and distance measuring system that's accurate to a couple of centimetres, all set up inside. So you can turn up to the ice rink, and within 1 hour you can be measuring to the same level of accuracy as if you had a GPS system.